peripheral mean inside your start. So timer inside your microcontroller, it is a one more component. Okay. What this timer is doing is like for example, see, let's take in this microcontroller, you don't have any other to calculate some time, you don't have any other component. So for example, like every 1 minute once, like you want to turn on some motor, and the motor has to run for like 3 minutes, and after 3 minutes the motor like again you want to turn off. So here you need one small time calculating event, correct, right? See, in laptop we have already some other like the time related things, so that whenever we open a laptop we can start a stopwatch, or in mobile like we can start stopwatch, so that like after 1 minute like you are turning on the motor is running for like 3 minutes, you're turning off the motor, again after 1 minute you're turning on the motor, 3 minutes it runs and you're turning off the motor. Got it, right? So this we have a reference point with our mobile, or we have like a laptop using the timing, like or we have a clock in our like a room, we have a clock, using that reference we are doing that activity. Now in this microcontroller has to do this activity. Inside the microcontroller there is nothing like no clock, nothing like that. I mean, I'm talking about like whatever we have wall clock, it doesn't have any wall clock, it doesn't have any other like a timing unit. So to do this kind of activity, the microcontrollers are coming with the inbuilt timers. Okay, in this PIC16F877A there are 3 inbuilt timers, that is timer 0, PIC16F877A has 3 timers, that is one is timer 0, timer 1, timer 2. Okay. So these are all the 3 timers. It is available inbuilt in this PIC16F877A. So today we are going to talk about only the timer 0. So using timer 0, what we are going to do is every 1 minute once, like we are going to make one LED on, every 1 minute once we will make one LED off. So already we have done in the first day activity also, one LED you are making on for 1 second, and 1 second you are making off. That is using some delay function is there. But today we are actually practically going to generate the delay. Okay, using programmatically, using the timer, we are going to generate the delay, and then we are making on and off for it, right? So that's timer is nothing but it's a one small peripheral which actually counts. Okay, what is count? What it does, like what the actual counter is doing is, let's go with like a general day-to-day life in our analogy. For example, you are in a room, okay, you are in a dark room, or like wherever like you are there, you want to calculate like every 5 minutes, you want to calculate like a 1 minute of time. Okay, so let's take, I'm saying you, from now you want to tell me like a 1 minute happened or not. I mean, you have to count the 1 minute. You don't have any reference in the wall, in the room, like you don't have any reference, just you are sitting alone. Okay, so you want to count 1 minute. Will you able to count? Do you have any reference? Okay, assume that like you don't have any other external reference, but as a human, in human body you have some reference. Correct, right? So there is a heartbeat count you can take. Okay, so how many count? 72. Yeah, good that some people. Okay, so very simple, like some or the other way, like you are counting the heartbeat. So because we don't have any other reference, so you are just counting your heartbeat every 72 times, like you can say that like a 1 minute happened. Correct, right? Now you want to count 5 minutes. Will you able to count? Yes. Correct. So every 360 count 5 minutes happened. Got it, right? That is what your microcontroller also doing. Inside the microcontroller, already we discussed, there is a one clock generator. Who is generating the clock? Oscillator. So oscillator is generating the clock. let's assume my microcontroller is generating like our microcontroller. What is the microcontroller working speed? 20 megahertz. Okay, very good. So 20 megahertz in the sense. So this is nothing but 20 into 10 to the power 6. So that is nothing but 2 7 zeros, right? Okay, it means in 1 second, how many clock it is generating? In 1 second time, how many clock it is generating? 2 crore. Got it, right? Because 2 7 zeros. Is everybody clear, right?
Yes, sir.
So in 1 second time gap, it is generating 2 crore clocks. Is that clear? So let's take, I want to count 100 millisecond. 100 millisecond means? How many 100 millisecond is 1 second? How many 100 millisecond is 1? 10 100 millisecond is nothing but 1 second. So then in 2 crore you remove 1 0. Got it, right? If you remove 1 0, what is this? 20 lakhs. So in 100 millisecond, how many clocks will be generated? 20 lakhs. Okay. Now again, 10 millisecond means 2 lakhs. Got it, right? So in 10 millisecond time, 2 lakh clock will be generated. If it is like a 1 millisecond, 20,000 clock will be generated. So you want to count 1 millisecond means what you have to do? Clock is generated, right? That clock you have to keep counting. So when 20,000 clock is generated, then 1 millisecond time is over. Again, sir, I want to count 5 millisecond. Then 20,000 5 times. That is a 1 lakh clocks. So when 1 lakh clock is over, then it means that now 5 millisecond time has expired. Okay. So now here you just need to do basic maths. Got it, right? The logic is same. The logic of the controller, how inside the controller, how timer is working. As we discussed, timer is actually a counter. Getting the meaning, right? So when you don't have any other reference, so inside microcontroller, the only reference is the counter. The only reference is clock. According to the clock counter, we are going to define now 1 millisecond happened, now like a 10 millisecond happened, now like 100 millisecond happened, now 1 second happened, or now 2 second happened. Got it, right? So everything we are going to decide based on the clock only. Is everybody able to understand clearly? That's the reason timer is called as actually it's a counter. Okay. Now what is the use of counter? So what kind of scenario we are going to use? So the timers we are going to use for delay generation. Got it, right? As we discussed, every 1 minute once I want to do some activity, or every 10 minutes once I want to do some activity. That is the delay generation we are doing. Or measuring of frequency of pulses. Okay, this you will understand. Once PWM we are discussing, that time you guys will understand about these two. Okay. So it's all about the timer, the purpose of the timer is on some certain event or some certain time period, like you want to do some event means there you need a timer. This you need everywhere, every time, right? See, you have a micro oven. Micro oven, what you are doing? You are setting some mode. For that mode, 20 millisecond the oven will be on. You are changing to different mode. The 30 millisecond micro oven will be on. You have a washing machine. So washing machine will be on for this many minutes. After this many minutes, it will make sound. It will make sound for this many seconds. Got it, right? Everywhere the time is needed. Got it, right? You have a simple automatic hand sanitizer. Whenever you show hand, the sanitizer will be open. Again, it will open for only this much time. It is not that open for all. Correct, right? It is the valve is not open for ever. It is just open for 10 seconds or like a 5 seconds or 2 seconds. So anything we are doing in our day-to-day life, any device you see, like everything is like a internally time counted. So timer is a very, very important topic. Clear? Okay. So these all again remaining things like you will understand. As of now you understand, for any time related activity, any like the delay generation, these all we need a timer support. Okay. So in this controller there are like three timers are there. Now today we are going to discuss about timer 0. And there is a two type of timer. One is up counting and other one is down counting. That I will come later. What is the up counting timer and other down counting? Okay. Now it's fine. So what is timer? It is a counter. What are the different timers? Three timers available in the PIC. That also we understand. How it is counting? That logic also we got. Clear? Now let's use this timer. How to use the timer? Okay, sir. Interrupt. You said how to use input output port. Like we discussed how to use it. Now similarly, we are going to understand how to use the timer. Using this timer, I am going to make some delay generation. That is, I am going to make LED on for 1 second and off for 1 second. Clear? So now we are trying to understand how to use this timer. So you want to use the timer means there is like a small procedure. So the procedure is procedure for timer delay generation. So set the timer pre-scalar in option register. Pre-scalar. Pre-scalar is nothing but so this PIC16F877A is how many bit controller? It is a 8-bit controller. I think I forgot to explain about that first day class. So it's a 8-bit microcontroller. Okay. So here it stands right. This 8 stands for 8-bit. Okay. So this 8-bit controller, inside a controller again what like registers you have. So many registers you have. So those registers are how many bit registers it will be there? It is a 8-bit controller, mean obviously the registers are also internally it is going to be 8-bit registers. Okay. Now let's take, you want to count like a 10 millisecond means, so roughly how much you want to count? You want to count like a 20 lakhs. Correct, right? So because for 1 second it is 2 crore. 100 millisecond it is 20 lakh. 10 millisecond means it is going to be like a 2 lakh. Okay. So if somebody is saying like a boss, you generate like a 10 millisecond delay, then the microcontroller what he will be doing internally is like he will be counting the clock for 2 lakhs. Okay. 2 lakh count like he will be counting. Okay. Whatever it may be the number, you just come to the concept. So 10 millisecond means like he is keep counting the clock. Okay, one clock happened, another clock happened. Already we know clock means what. So a device, oscillator is generating 5 millisecond for some period, 0 millisecond for some period, 5 volt for some period, 0 volt for some period, 5 volt, 0 volt, 5 volt, 0 volt, 5 volt, 0 volt. So like that, oscillator is generating the output voltage. Assume that this is oscillator. From this, from this 5 volt is coming, 0 volt is coming, 5 volt is coming, 0 volt is coming, 5 volt is coming, 0 volt. It is in a regular order. That order is like again every one. So this we are calling it as a one clock. So this 5 volt, got it right? So this 5 volt and 0 volt, this we are calling it as a one clock. Okay. So actually we are drawing a diagram because for people, everybody, if I put like this, no, people are not able to relate. That's the reason in everywhere in the like a diagram it is given like this. Got it right? But actually what internally is happening, just a 5 volt for off time period and 0 volt for off time period. 5 volt, 0 volt. So this we want to see properly means it is connected as a like a kind of waveform. Got it right? So this we are calling it as a one clock. Got it right? So like this, what time delay you want to generate, accordingly there is a one small counter. The counter what he will do now, that is your timer. The timer what he will do, he will be counting, okay, 1 clock, 2 clock, 3 clock, 4 clock, like that you will be counting. Now let's assume that it is counting like a 20 lakh time. You have how many bit register? 8 bit register. In 8 bit register, what is the maximum value of your decimal number? 255. Okay, but you want to count 2 lakh, you want to count 20 lakh. Will you able to count using internally? Is the microcontroller will able to count? He will not able to count. Getting right? So that we need a different mechanism. So that like we want like some other shortcut. Let's assume somebody is again coming back to the like the odd bit. Okay. If somebody is saying like you count like 1 minute, you will be counting 72 odd bits. Somebody is saying like pass, you count like the 10 minutes, or you count like 15 minutes. So 15 minutes means like first 10 minutes means it is 720, like another 360. So it will be 1080. Correct, right? So 1080 odd bits you need to count. That you can count in a two different way. One is like you're taking 1, 2, 3, 4, 5, 6 like that. You are keep counting the odd bit like up to 1080. This is one way. Here you have one. Assume that you have one 8-bit register. In that 8-bit register, but you cannot count up to 1080. That is a challenge. So that we are going to the second way. Second way, what you are doing is you are taking two register. One register, what it will do, whenever it is reaching 72, the second register it will count 1. First register again it will be reset to 0. Got it right? Again it is counting from 1 to 72, count to 2. 1 to 72, count to 3. 1 to 72, count to 4. 1 to 72, count 5. Okay. So when the count here it is reaching 10 minute over. Got it right? So you are splitting the operation. Instead of doing it as a single stretch, just like 1 to 1080, what you are doing? 72, 1 count you are doing. 72 you are doing 2 count. So that like when this second register is reaching 10, your actual timer 10 is over. Or second, you want to like a 15 minutes means when it is reaching 15, the time is over. Now you take. So even if you want to count for like not only 15 minutes, you want to count for like a 150 minute also is possible. You want to count to 250 minute also possible. Correct, right? Because here it is going 0 to 72 only. Here it is going like a maximum it can count up to 250 means 250 minute it can count. Everybody following this logic, right? Because that's what is your pre-scalar. இது புரிஞ்சனா உங்களுக்கு டைமர் முடிஞ்சு. Okay, that's the internal whole mechanism of the timer. Okay, again I'm just like recalling. So as we discussed, like you are in a just idle place, somebody is asking you to count the time. Okay, from now like you are counting like 15 minutes. So the only way is like in our human body we have a reference heartbeat. So every 1 minute, like within a 1 minute, like a 72 heartbeat will happen. So what we are doing, we are counting the heartbeat. Okay, somehow or the other way, like you are keeping hand or you are checking the pulse, whatever the way, like you are assume that you figure it out the way. You are keep counting. So from 1 to like 1080 is reaching me the 15 minute over. But assume that you have a restriction, you have only, you can count like a 8 bit only you have a register. So using that 8 bit you can maximum you can have value only 255. So in that like you are not able to count up to 1080. So that you are going with a different way, that is you are taking two registers. One is like it is going to count only 0 to 72. Whenever it is reaching 0 to 72, you are incrementing 1. It means like 1 minute expire. 0 to 72, 2 minute expire. 0 to 72, 3 minute expire. So in this case, even not only like a 15 minute, you can count up to like a 255 minutes. Because you are in this register also limit is 255. So once it is going beyond 255 minutes, then only it is the challenge is going to come. Clear everybody? Okay, that's what is your pre-scalar. Because you cannot keep counting up to like some n number. Here you are trying to count lakhs, you are trying to like count like thousands. Where you have only 8-bit register, it is not possible. Okay, so pre-scalar, I'll give the definition for pre-scalar. Okay, but the concept you understand. Concept is only like When it is counting, it has a challenge to count beyond some limit of number, that you are going to segregate it as a, like a multiple different way of counting. Clear? Okay, so that's prescaler. And next, prescaler is clear. Coming to the next, calculate the load value. Okay, now you are setting 10 millisecond as a delay mean. 10 millisecond you cannot give directly. Okay, so some register is there. In that register, you cannot set a 10 millisecond delay I want. In our mobile phone, you want to set alarm means directly you are setting. Okay, morning 6 a.m. Okay, and 7 a.m., 6:30 a.m. something like that. You are setting timer. Directly we are setting. But in this microcontroller, during the programming, you want to set 10 millisecond delay means you cannot directly set like okay, some register or some variable is there. In that 10 millisecond, if you set, it will not work. There is one formula. In that formula, you apply this 10 millisecond. You have to solve that formula, and you will get one number. That number only you are going to store it into that register. That number is called load value. Got it, right? So you are going to set the time delay what you want that as a different way, that is as a load value. Very simple. ரொம்ப சிம்பிளா சொன்னா நீங்க என்ன டைம் டிலே ஜெனரேட் பண்றீங்களோ அந்த டைம் டிலேக்குன்னு ஒரு நம்பர் நீங்க கிரியேட் பண்ண போறீங்க. அந்த நம்பரை வச்சு தான் நீங்க இவ்வளவு டைம் டிலே எனக்கு வேணும் அப்படின்னு சொல்ல போறீங்க. Okay, see what delay you are trying to generate for that value, for that time, using that formula you are going to generate one number. Using that number only you are going to set the delay. That's all. Indirectly you are going to set the delay. That's all. Not too complicated. So calculate the load value. That is nothing but using that formula you are going to calculate the load value for recorded time. 10 millisecond means for 10 millisecond you will get one value. For 20 millisecond you will get one value. For 1 millisecond you will get one value. So for what time you want, that time like you are going to generate that load value. And that load value you are going to update into this register TMR0. Clear? In this register only you are going to set that the delay. That's whatever the number you got, that number you are going to set. That's the procedure. Because INT-CON you are using mean for that there is a one register. Port B you are using mean for that there is a some set of registers. Port C you are using mean there is some register. Similarly, when you are using timer 0, this is the register TMR0. In that register only you need to set that load value. Clear? Program is very simple, very simple program. Okay, I want you to understand the only concept. So for any question? Okay, so the program is as include pic.h as defined okay, so these are all regular process. You have unsigned character variable I is equal to 0. Void interrupt